We made it. We're all the way through Unit 5. So you have your Unit 5 test after this quiz. You have your midterm, and then you're going to be done with the first half. Hey, and if you're only taking the first half, you're done. Yeah. So celebrate. Just make sure you guys don't give up. Please, 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 let me know what questions you have. I'm here for you. All right, here we go. This one is just talking about, they call them polynomial identities. So it's just really things that we've seen before. There's only two that we haven't seen before. We've seen the difference of squares. We've seen the difference of cubes. We've seen the sum of cubes. The only two that you're going to see that you have not seen before are these two right here. All they're going to do is ask you on the quiz, is this an identity? And you're going to look at your notes and be like, yeah, that looks the exact same. That's the identity. Or you're going to look at your notes and be like, no, that looks different. That's not an identity. So don't pay too much attention to these. I've never used these in pre-cal. I've never used these in calculus. I've never used them in UIL maths. I've never used them in algebra 2. So don't worry about them too much. Just be able to answer the questions on Apex when they come up. All right. The last one is the quadratic formula. You guys should already know this by now. We've been dealing with it a lot. So last thing we're actually going to talk about is something called factoring by grouping. So what we're trying to do is create common factors that we can factor out. It's helpful with things that are like 4 terms, sometimes more than that, but mostly ones with 4 terms. So let me show you how it works. What I notice here is if I look at these two terms, they both have a y in common. So if I factor out a y, that creates an x plus 2 factor. Then, if I look at these two terms, they have a 3 in common. So if I have a 3 that I factor out, they make 2 plus x. Well, 2 plus x and x plus 2 are essentially the same factor. So if I rewrite this to help you out, I have y times x plus 2 plus 3 times x plus 2, right? So that now, check it out, they have a common factor of the x plus 2. So what I'm going to do is kind of weird, right? Just like if I had ya plus 3a, I can factor out the a such that I have y plus 3. My a in this case, this a right here, is going to be acting as the x plus 2. So I'm going to factor out that x plus 2, and I am left with the y plus 3. That is called factoring by grouping. I'm looking at groups of things together, seeing what I can factor out, and if it makes a common factor, then I can factor out the common factor. I just said factor a lot. All right, let's try some more, see what you can do. Try to catch along. If you can't, just email me. We can always set up a Zoom session. I know this stuff is kind of tricky at first. All right, so even for me, it's kind of tricky. But the first thing I notice here, and you don't always have to take the two right together. So I notice 4x cubed and x squared. So I'm going to rewrite this. So I have 4x cubed plus x squared. Then I have to have plus y plus 4xy. Because now if I look at this group and this group, these have an x squared in common. So if I factor that out, I'm left with 4x plus 1. These have a y in common. So if I factor out the y, I have 1 plus 4x. So again, just like in the last one, that 4x plus 1 and 1 plus 4x are the same exact factor. So I can factor it out, so 4x plus 1 times x squared plus y. That's it. That's factored complete. All right, moving on. So I have x squared minus 35yz plus 5xy minus 7xz. Well, just looking at these two don't have anything in common. So the next I would look at would be these two, x squared plus 5xy. I could factor out an x. So now I would have to create, that would be x plus 5y. So if I factor out, let's try it. If it doesn't work, it doesn't work, and you can kind of show, I see how I'm thinking too. So if I group this x squared minus 7xz minus, and I'm actually going to do plus 5xy minus 35yz. So I'm going to try this grouping first. If it doesn't work, again, you can always try something else. So here, I can factor out an x, and I have an x minus 7z. And then with these two, I'm going to factor out a 5y. So plus 5y times this would just be x minus 7z. Hey, it worked. Cool. So if it didn't work, these factors would be different, and we'd have to try some other grouping. So I know these first two didn't work. You could try the outside 2 and the inside 2. Maybe we'll get to one in this video that we have to do that. So now, since these factors are the same, I will pull it out front. So x minus 7z. And then I'm left with the x plus 5y. There it is, factor complete. All right, moving on. So here, 5 and 2 don't really have a number in common, but 5 and 35 do. It's 1 and 7. And then if I look at the 2 and the 14, that's also 1 and 7. So I'm going to rearrange this. So I have 5x cubed minus 35x plus 2x squared minus 14. So if I factor out 5x from this, I have x squared minus 7. And then if I factor out 2x from this, I have 2x times x minus 7. I can't factor out that x, I'm sorry. That's just x squared minus 7, because that doesn't have an x on the 14. My bad. So now I can factor out that x squared minus 7 times 5x plus 2. Something else Apex may do, they may take this factor right here, this x squared minus 7, since you can technically solve it, and you would get plus or minus root 7. They may factor that more. So they may say x plus root 7 and x minus root 7 times the 5x plus 2. That may be what they say is factored completely. They could also say that is, so just be careful. The reason I took it off to the side right here is because we have an x squared. And if we have an x squared, we know we're going to get two solutions out of that. All right, last example. All right, sorry. So here, I noticed these two have a y involved, these two don't, so I'll probably have to factor out the y. So I'll rearrange it such that I have been doing mostly. All right, so I can factor out the x, so x times x minus 5. And then I'm going to factor out a negative 5y and see what happens. So negative 5y times x minus 5. Yeah, so notice that created the factor of x minus 5. So don't always just go for the easy one. I can also take out that negative, and this changes that sign as well, such that they have the same factors. If they don't create the same factors, see if you can factor out something else to create the same factors. So now I can pull out that x minus 5 and make x minus 5y, and there it is, factored completely. All right, it's been super fun. Please, 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 you guys, seriously though, like, email me any questions you got, monkeys and bananas. If you want to talk about them, that's fine too. All right, let me know. I'm here for you guys. Congratulations, you're almost there. All right, I'll talk to y'all soon. Bye.